In Chapter 6, we're going to explore the topic of time value of money. We're going to use Excel to solve for present value or future value or payment, number of periods, or the interest rate. We're going to use the type column only if we have a situation where the payment is due right away on the first date. Otherwise, the default in Excel is for ordinary annuities, where the first payment is due at the end of the period. In the first question, we want to know what amount should be deposited today. So we're going to be solving for present value. If a balance of $1,000 is desired 5 years from today, earning an interest rate of 3%. Now there's no payments in this problem. We'll only use this if it talks about a recurring payment every single period. We don't have that in this particular problem. So we're going to solve for present value, and we'll get this box. We can just drop in our variables, our rate, number of periods, payment, and future value. $863 would be deposited today, and in the future it would accrue to $1,000, assuming 3%, and that's after 5 years. In the second scenario, it says if $1,000 is deposited today, and we're going to earn 4% interest, how much will be in deposit at the end of the 3 years? So it's asking us to solve for future value. 3 periods, no payment again. I'm going to solve for future value. I'm going to drop in my variables, my rate, number of periods, payment, and PV. So $1,125 would be the future amount after 3 years. For the next case, we've got a car that you're going to purchase for $30,000, so that would be the present value. We're going to finance it at 8% for 48 months, and we want to know what the monthly payment will be. One key aspect of this problem is that it's asking us for a monthly payment. We want to make sure that the variables that we drop in are all listed on a monthly basis. 48 is fine, but this 8% will need to adjust because that's going to be an annual rate. So over here, when I drop in my rate, I'm going to just divide by 12. Number of periods, 48. Future value should be 0 because we'll have it paid off. So I'm going to solve for payment. I'm going to drop in my rate, my periods, present value, and my future value. So my monthly payment would be $732. Number 4, at what annually compounded interest rate must Dave invest $25,331, that would be my present value, to earn a future value of $50,000? In 6 years, no mention of payment, and we're going to solve for rate. I'm dropping in my variables. If you get this error, Excel can't read what you've entered because it's looking like you have 2 inputs, a positive and a positive. But really what it is you're going to invest 25,331, should be indicated as a negative sign, and we're going to achieve 50,000. Now it's able to calculate that return of 12%. In number 5, Carrie owns a garage and is looking to purchase a machine for $14,280. So she's trying to weigh, should I spend this amount of money? And she's going to look at all of the cash flows that she's going to achieve by spending that investment. Now, we're not going to take the 2,900 times 8 years because we know that we have to wait for these cash flows in the future. And so we need to discount those cash flows because we have to wait for a longer period to receive them. So let's figure out what the present value is of those cash flows and compare it back to the 14,280, and then we'll see if we have an investment worth pursuing. We're going to solve for the present value. There's no future value or salvage from this situation, but we do have a payment of $2,900. Number of periods is 8, and we're trying to achieve an 11% return. We'll drop in our variables. And in this case, we've got $14,924 is the value of all of these payments, assuming 11% return. We would go ahead and we would purchase this machine because we would spend $14,280, but we would achieve $14,924, assuming 11% return. As long as this number is greater than our initial investment, we would consider that project. The sixth one, on January 1st, Brown purchased 200 of the $1,000 face value bonds, and they pay 9% interest, and they mature in 10 years. The yield is 11%. How much did Brown pay for the bonds? Okay, so we're going to solve for present value in this scenario. The future value is the principal amount, which is the 200 times the 1,000. Our payment is based on this face value of 200,000 multiplied by the 9% interest rate. The number of periods is 10 periods, and the rate is 11%. So we're going to solve for the present value discounting at 11% because that is the yield, and so that's going to be our market rate. We'll drop in our variables. And the purchase price was $176,443. The maturity is 200,000. It was sold at a discount, and that should make sense because our market rate is greater than our stated rate. Whenever we see that scenario where our market rate is greater than our stated rate, our bond is going to sell at a discount. The expectations are higher than that of what the bond is actually paying, so it has to be discounted upon sale. In our last case, we're going to assume a 12% cost of funds, and we're trying to determine which option would be the best. So option A is purchasing for cash $610,000, straight up cash for this building. So the present value is $610,000. No computations that we need to perform. The next thing is we can lease it for 25 years with annual payments of $70,000 being made at the beginning of the year. The beginning of the year is going to be important in this problem because we're going to need to change the default in Excel to an annuity due. So we're going to put just a note here so that we remember to do that. The annual payments are $70,000. No future value. Number of payments we said was 25. And we're going to solve for the present value. We're going to need to drop in 12% for our interest rate. Number of periods is 25. The payment is 70. The future value is 0. And here's where we're going to change it to an annuity due of 1. And you'll see it down here in case you forget. Payment at the beginning of the period, enter a 1 here. And so the present value of that all of those payments would be $614,902. So that's actually more expensive than the $610. Let's indicate that as a negative too, just so it's comparable. We're going to pay $650,000 up front, but we can rent out the space for $6,000 annually for 25 years. That's going to be an inflow to us. So let's figure out what the value is of $6,000 coming in over 25 years. Rental will be received at the end of each year. So that's going to be an ordinary annuity. So we will receive $47,059. Let's indicate that as a negative so it will come out as an inflow. $47,059 will come in. That's going to offset the $650,000 cash outlay. After I indicate that's a negative, let's sum these up and see what the total outflow is. So A is going to be 610, B is 614, and C is 602. So you can see in this case, the cheapest for us would be scenario C, because the present value of all of the cash flows and the lowest is going to be in scenario C. So we would choose C.